Hi everyone, in this video today we're going to be talking about volume. Now volume is the amount of physical space inside a three-dimensional object. So we're dealing with 3 dimensions now. So 2 dimensions we just look at length and width, so it's a flat shape, whereas in 3-dimensional objects we have that extra dimension which is usually called depth, or some people call it height. So we're looking at how much space is inside that 3-dimensional object. Now the formula for this, a common misconception is people think it's just length times width times height, which is incorrect. That only works for certain shapes such as a cuboid, a cube, rectangular prism. So volume is the area of the cross-section times the height or that depth, that extra dimension. So cross-section, this part here, is the part of a prism. So when you're looking at a shape, if you were to picture cheese, for example, or you were to picture a rectangular prism like this, if I were to slice the front, I should see the same shape and the same size every single time. That's why we call it a prism. So if I were to slice this whiteboard marker eraser right here, I would see a rectangle, the exact same shape and the exact same size every single time. So the cross-section is that face. If you picture slicing cheese or Toblerone, you would have a triangular prism if you had Toblerone chocolate. So what you need to identify is, right, what is the cross-sectional shape? So if we're taking this shape over here, for example, if I look at the front, I can see I actually have a square here. So if I've got markings which should be given to me, I find the area of that first. So the area of my cross-sectional shape, if I know it's a square, is just 2 by 2. And we know area is in square units, so I have an area of 4 centimeters squared. Now from there, sorry, that's incorrect, that should be there. From there, I then say, okay, if I want to go that step further for volume, I then have to multiply that area by the height or the depth. So the part that makes it 3D is this extra part here. So I multiply 4 centimeters squared by that extra dimension in there, and I will get 20. Now because I have centimeters squared there and I've got an extra centimeters here, it's like having that centimeters to the power of 2, centimeters to the power of 1. So altogether I have centimeters cubed. Okay, essentially it's how many cubes, how many 1 centimeter cubes can fit inside that. So you've done your first step, great, you know you found the area of your cross section, and then from there you just multiply it by the depth. Same with this question here. So my area of my cross section, now again, people just go length times width times height. Great, that will work for this, so you can go and do that straight away, that's fine. It's when you get to triangular prisms and more complicated shapes, some people still use that formula and that doesn't work. So this formula will work all the time. So again, my cross section, what shape can I see at the front? You have a square, so find the area of that first. So the area of your square or your cross section is 8 meters by 8 meters, which gives me 64 meters squared. Then from there, I work out my volume. My formula says I take my area of my cross section and I multiply it by my height or my depth in there, which is this line here. Because it's got a marking, I know that it's 8 as well, okay? So if I work 64 times 8 out, I can work it out like so, or however you're going to be working it out. And then from there, I will get 512 meters cubed because I've got my squared and then just my meters there, okay? So that is how we find the volume of cubes, cuboids, rectangular prisms, or pretty much anything. I'll do another video on triangular prisms, but this is just an introduction to volume.